Hey everyone, I've created this Babylon QuickStart repo in GitHub that you can go and clone, and you're going to be able to start using BabylonJS almost immediately. This setup includes TypeScript, the AmmoJS physics engine, and BabylonJS, of course. So let's get started. For this tutorial, I'm assuming you have Git, Node.js, and VS Code installed. The first thing we'll need to do is we're going to need to clone this repo. So let's go to code and we're going to say copy this URL. Let's open a terminal and we'll say git clone, and we're going to paste this URL and hit enter. You can see it cloned there. Now we're going to cd into the folder that we just cloned. So if I clear this and say ls, we can see the folder's called Babylon QuickStart. So we'll cd Babylon QuickStart. And now we're going to run npm install to install all of the project dependencies. So npm install, hit enter, and this will take just a few seconds. Once our dependencies are installed, we can just start coding with this by typing code or opening this in VS Code, which is what I'm doing here. Once we have this open in VS Code, you'll notice that we have a node modules folder. Yes, I trust the authors. Node modules, because we ran npm install, we have a package lock.json, package.json, all this stuff, which is fine. Right now we just want to build it and run it to see what it looks like. In order to do that, we can look in our package.json file and we see scripts here for build and start, which is great. That means we can go like this, open a terminal, and this is very tiny, so let's increase the screen size here. Perfect. And we can say npm run build, and this is going to build our initial code here, and you're going to see a dist folder gets created. Once that's complete, the next thing we can do is run npm run start, hit enter, and we're going to let that run. You're going to see it opens a port on 8080, so we want to go to this localhost 8080, and I already have that up, I believe. So yep, I can close the GitHub now, and I'm going to refresh our localhost 8080. And you'll see a nice kind of sane starting point for your BabylonJS project. You'll see that physics is already incorporated and that we are set to go with like a cube and a plane. Here you can see the cube kind of bounces on the plane. The cube's a little bit extra bouncy, did that on purpose. Let's see it one more time. All right, here it goes. So this is kind of the starting point for your project. You've already got ammo incorporated with the gravity. You're able to stop the cube from falling through the plane, etc. We got lighting, we got a camera, we got all the kind of sane defaults you need to build whatever you want. It's a great way to kickstart your development process. If that's all you wanted and you want to get going, that's great. If you'd like to see the details of this, of these starter files, then stick around and we're going to go through those now. Alright, so let's go through some of these files and just, see what's up, see what this is made of. So we'll start with this package.json. You can see a list of all the dev dependencies here and all the dependencies here. These were all installed when you ran npm install. There's no need to do them individually installations. You just npm install after you clone it and everything's installed for you. Package lock.json gets generated, so you don't need that. The readme.md, that's what this video is. This is just in readme form, a little easier to see it. We have the TypeScript configuration file. Things to note here, I have no implicit any set to true. You can of course change that to false if you want, and just some different configurations here. Feel free to change those up, add your own, etc. The Webpack config, some of this was copy-paste, going to be honest. A lot of it was Googling, and I don't necessarily know everything, but the one thing that I do know I had to add was this fallback, file system false, path false, in order to get AmmoJS to work properly. Here you can see it's served on port 8080, and you can see the hot server set to true. Yeah, I'm not going to claim to know a lot what's going on here. Just the fact that we're serving from the index.html file, which is in our public folder, which is up here. And I can just check out this index.html. You'll see there's no canvas in here. It's because we're creating the canvas in the JavaScript file itself and dynamically adding it to this body of the HTML. The node modules folder gets created when you ran npm install, and that just has all of the dependencies in it for the project. The dist folder got created when you ran npm run build, and that has the bundled JavaScript code inside of it, and this is the code that gets created when Webpack does its magic. Next we have the public folder. We already saw index.html in here, and we have a gitignore file. Our gitignore file is just saying, hey, when I push this code to GitHub, I want to ignore the dist folder, node modules folder, and the package lock.json file because those just aren't necessary. Now the important stuff, let's go into the source folder. It's all important, but this is the actual code, right? So in the source folder, we have our app.ts, and this is where everything starts from. So let's click into there. Let's do a broad overview of this app.typescript function. So we have some imports up top. You can see these three are from our own files. This scene, make round, make cube, and the ammo stuff from the ammo physics engine. Our function has to be async, our main function, because we have to wait ammo inside of it. So we're waiting for the ammo code to load. We do some physics stuff right from the documentation here. We enable physics on the scene. You can see we got gravity set here, approximately -9.81. And we make our cube, make our ground, and then this, again from the documentation, we run our render loop so that we're constantly rendering the graphics, or the graphics that we want to render. So that's kind of the main function. We want to look into some of these specifically. The scene, we'll start there, and then we'll look into how we make our cube and ground. So let's go with the scene first. Inside of our scene, we have multiple functions up top here, but mainly we'll start at the bottom and kind of work our way through those. So we have our canvas variable equals create canvas, and so here's our create canvas function. We create a canvas element on our HTML document, give it a width and height of 100. We give it an ID. We haven't really use that, but we give it an ID there, and then we append the canvas to the document body in the HTML, which is here. So this is dynamically added in here now. Back to the scene. Yep, and then we return the canvas out of this just so we can use it and pass it on later, which is here. Next we create the engine. Again, we pass the canvas into the engine to create a new engine. That's just, again, out of the documentation. The next thing we want to do is we want to make a scene. Well, we want to make the scene for BabylonJS. So we have our make scene function. New scene, we pass the engine in. Again, out of the documentation, just kind of. So inside of make scene, we have the create camera, create light, and set background function, and these are kind of the basics we need in order to be able to view our cube and platform that we have the cube bouncing on. So let's go up here and check these out. We'll start with the create camera function. First we set the alpha and beta of that camera, and that pretty much means like there's these two arcs, and depending on what we put in there, in our case math.pi divided by 4 and divided by 3, that depends where the camera sits on the up down arc and the kind of horizontal arc. So vertical and horizontal arcs like this, that tells us where the camera sits, and these tell us that it's going to sit kind of off to the kind of on a diagonal, and I would say if you think of it as like top, right, left, and then right, left here, it kind of sits off in the corner here and is able to look down at the target object. So the radius is 8, so that's 8 units from the 0, 0, 0 point of our project, so it goes 8 out, and then the target is looking at 0, 0, 0 at the point. So the camera's up here and it's looking down at the plane and the cube in the center of the project. And then we pass all these variables into a new arc rotate camera, and we attach a control on it so that we can manipulate the camera with the mouse. Next we have the create light scene. This one is much more straightforward. We create a new hemispheric light. We give it a name so that we can use it later if we want to, and we give it a where we want it positioned, in our case 110, and we pass it the scene. When we set the background color, so we do scene.clear color, a new color 4, so the first 3 are RGB, the last one is the opacity, so we're just setting it to all 0 so it's black, and then the opacity is 1 so it's not, so it is completely opaque and there is no transparency. So yeah, that's it for make scene, and then down here we call these things. We get our canvas, we pass it to the engine, we get our engine, and then we make a scene. Now we're back in app.typescript, and you can see that now that we have our scene imported here, we can enable physics on that scene, and now we need to make the cube and make the ground are our last steps. So we're going to go into cube.ts. You can see we have some imports here from Babylon, and we are importing our scene because that needs passed everywhere. Okay, and then we export our function makeCube, and we declare a variable called cube. And there's this mesh builder.create box on that, and you can see we can name it, and we can give a size to our cube. Changing the cube position to be 1 on the y-axis so that it starts up above the plane and it falls down to the plane. We then add physics onto the cube, giving it a mass of 1, so the heavier it is, the quicker it falls, I think. And then the restitution, I think about this as the bounciness of the cube. When it hits that plane, how much do we want it to bounce? I want it to bounce a lot, so I made my restitution 0.9. And then we pass it the scene, and we return the cube from here. Over to the ground. In the ground, same sort of setup. We have our make ground function. We give it a size, and we create our ground with, we just call it ground for now because there's only one ground in the project. We give it a width and height of our size 4, and we pass it the scene. Give it physics. We pass in the ground from up here. A physics imposter.box imposter this time. Mass of 0 because we don't want it to fall. We don't want our ground to fall too. We want our ground to stay, right? And restitution again of 0.9 because I want that bounciness when the cube hits the ground. I want it to bounce off of each other quite a bit, at least quite a bit for that a cube can. So let's go back to our app.ts and see all this one more time. We import our scene engine, make ground, and make cube that we talked about. We do all our physics setup. We make the cube, we make the ground, and then we run our rendering loop, and that's what allows us to see this final product. And of course, here's our final product. You can see it's a little bit glitchy. My computer's running just a little slow, but you can see all the bounciness created between the plane and the cube. And again, this is just a nice kind of sane default setup for you to get started, a Kickstarter setup for you to get started on any BabylonJS project you want. All you have to do is follow those couple instructions at the beginning of the video, or you can just look at the readme.md and you can just follow these and you can get started right away. The rest of this video obviously was just explanation, right? So you can expand on this, you can make more than your cube and ground, you can make other files, you can add lights, add cameras, etc. All kinds of stuff. There's all kinds of things to be explored. So I hope you like this, and I hope it gives you a solid foundation from which you can build in order to create awesome things with BabylonJS and AmmoPhysics. Thanks for watching. See you in the next video.